Hello again, and welcome to Crazy Math Productions. Today we're looking at solving absolute value equations in one variable. Now, we consider the absolute value of x. When we're talking about it algebraically, it's actually quite interesting because we're going to have to split it into separate cases. Consider if we have positive 3. We take the absolute value of positive 3. Well, the absolute value, remember, we're talking about absolute value, we're talking about the distance from 0 on the number line, distance from 0. So how far is 3 from 0 on the number line? Well, I could graph it. It is 1, 2, 3 units. So the absolute value of 3 is 3. Well, you notice from an algebraic perspective, we've taken x and we've done nothing to it. So if x is positive, we just leave x as x. Well, that's if it's positive. What if it's 0? Well, how far is 0 from 0? It's 0 units. What if it's a negative number? Let's say negative 3. Well, if we look at the absolute value of negative 3, again, it's distance from 0. So negative 3 to 0 is 1, 2, 3 units. So the absolute value of negative 3 is positive 3. Well, here's the problem. If we think about it algebraically, we've had to take the opposite of x. The opposite of negative 3 was positive 3, but I only did that when x was negative. So if x is a positive number, you leave it alone. You just leave x as x. If x turns out to be 0, you call it 0. If x were negative, we'd have to take the opposite of x so that it would end up positive. Because again, the absolute value can only be 0 or positive. It cannot be negative. So algebraically, we have to split it into 3 cases. Now consider, what's the absolute value of 8? Well, remember my definition here. It's the distance from 0 on the number line. So if I were to graph a little number line here, there's 0. It's asking what, in what situation would the absolute value, the distance from 0, be 8 units? Well, let's go 8 units from 0. 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 units away. So the absolute value of x equals 8. X could equal positive 8. But is that the only possible direction I can go from 0? Well, no, I could go left. 1, 2, 3, 4, 5, 6, 7, 8. So I could go left 8 as well. And that would give me a negative. So x could be a positive or a negative 8. Okay, so in these examples, we're going to solve each absolute value equation systematically. Now, first I'm going to do the traditional method, and then I'm going to do sort of a dumb version of it, just something, a little scaffolding to try to help you remember it. So number 1 here, we have absolute value of x plus 6 equals 8. Well, here's the thing. What's in here, the x plus 6? If what is in here ends up positive, then we're going to leave it alone and say x plus 6 equals 8. Or we could have a different scenario. What's inside the absolute values could end up a negative. Well, if it's a negative, we're going to have to take the opposite of this whole thing. Well, this is a little complicated to work with. So what we usually do, you could think of this as a negative 1. Negative 1 times x plus 6 equals 8. I'm going to divide by negative 1 on both sides, and we're going to get x plus 6 equals negative 8. So going with that traditional definition there, um, if x plus 6 is positive, we leave everything alone. If x plus 6 were negative, we would have to take the opposite, which is saying negative 1 times. But I'm just going to move that negative 1 onto the other side. So what we're usually going to do, just practically speaking, we're going to say x plus 6 is 8 or x plus 6 is negative 8. You have these two cases. Again, it's sprouting for this definition here, but we end up with this. Now, once we split this into this case, now we can actually work on each part. We can subtract 6 from both sides. X equals positive 2, or subtract 6, x equals negative 14. Now, it is a good idea to check it, make sure that this makes sense. So plug in 2. 2 plus 6 is 8. Absolute value of 8 is 8. So that works. Negative 14 plus 6 is negative 8. Absolute value of negative 8 is positive 8. So it works both ways. Now, that's sort of a mouthful to remember. What I'd like you to think of is the traditional Lewis Carroll, Alice in the Looking Glass, Alice in Wonderland, if you will. Basically, what happened was you had Alice who was looking through the mirror, and she sort of saw this parallel dimension open up. It wasn't quite like hers. If you picture Alice looking through the looking glass, and then suddenly there's this sort of parallel world that opens up through that mirror. And again, she's sort of in this nice, positive world, very nice. And then she looks through, and she actually steps into this sort of darker, very mysterious parallel dimension, parallel world. And so what I want you to think of is, in this situation, think of this absolute value as sort of the looking glass, if you will, the mirror that's going to open up these two parallel worlds. We have 2x minus 5 equals, we have the sort of positive world. We also have this dark, mysterious, negative world that's going to open up as well. So again, this is really the meaning of the traditional definition. But if you want sort of a little bit of scaffolding to try to help you remember that, think of the mirror here. We open up this positive world. We also have this negative, mysterious, sort of dark world here, this negative world. And now we're able to actually do it. But we can't do this, we can't work on any of this until we've acknowledged that we have these two sort of parallel worlds out of the mirror. So we're going to add 5 to both sides. We have 2x equals 18. We can divide by 2 on both sides and get x equals 9. Or we could add 5 to both sides, and we get 2x equals negative 8, and divide by 2, x equals negative 4. Now, but before I confirm that this is completely true, let's plug this back in. Plug in a 9 here. 2 times 9 is 18. 18 minus 5 is 13, and the absolute value of 13 is 13. Now let's plug in negative 4. 2 times negative 4 is negative 8. Minus 5 is negative 13. The absolute value of negative 13 is positive 13. And so this does work very nicely as planned. Now here we start to get into some new territory. You notice that when we have the looking glass, the mirror by itself, we can open up these two sort of parallel worlds, the positive world and the dark, mysterious, negative world. In number 3, we have some things other than just the mirror. We have this plus 5. Well, we're going to have to deal with these. We cannot have this plus 5. To be able to look in the mirror, we have to have the mirror by itself. So, absolute value of 3x minus 6 plus 5, we're going to subtract 5 from both sides. Basically, we're pretending like this is almost a variable in and of itself. We're solving for the mirror. So the absolute value of 3x minus 6 equals, this is 42. Now we have the mirror by itself. Again, Alice looks into the mirror and it opens up these two parallel worlds. One of the worlds is nice and positive and pretty, or she has an opportunity to step through the mirror and enter this dark, mysterious, negative world, version of her own world. Now that we split them into the two cases, the two parallel dimensions here, we're going to add 6 to both sides. You get 3x equals 48, divide by 3, and x equals 16. Or, we're going to add 6, 3x equals negative 36. Again, we're going to divide by 3, and x equals negative 12. And again, we want to plug these back in, make sure they work, but for the moment, this will do. Let's continue. Now again, there's extra stuff here. We have 3 times, and we have minus 4, both of which is keeping the mirror from being by itself. So let's try to get the mirror by itself. Let's isolate that mirror, which is the 7 minus 4x. So first I'm going to add 4. Just like if this were a variable, I would get rid of addition subtraction first, and then multiply divide. So now we have 3 onto the absolute value of 7 minus 4x equals 9. Now, we've got multiplication here. To undo the multiplication, we're going to divide. And we end up with the absolute value of 7 minus 4x equals 3. Okay, so we have the mirror by itself. Now we have the chance to look through this mirror like Alice did and open up these sort of two parallel dimensions, two parallel worlds. So 7 minus 4x equals 3, the nice, happy, positive dimension, or 7 minus 4x equals negative, the dark, mysterious, negative dimension, parallel world. And so now we have the opportunity to work on each. But we cannot solve anything until we've looked through the looking glass here and open up these two parallel possibilities. Now let's keep, change. That's obviously not necessary, but we're going to go there. Let's subtract 7 from both sides. Negative 4x equals negative 4. And divide by negative 4. X equals positive 1. Or we can subtract 7 from both sides. We get negative 4x equals negative 10. Divide by negative 4. And x equals positive 10/4 is 5 halves. And don't be afraid of getting these fractions. In fact, fractions are quite common. And there we go. Okay. Looking at number 5, at this point I would encourage you, go ahead and pause the video, see if you can do this on your own, and then play it, rewind it, until you're able to get it correctly. Let's go ahead and start. The mirror, the looking glass, is not by itself. We need to solve and get this by itself. Okay, we're going to multiply both sides by 3. A third of 3 is 1. We don't really need to write the times 1. And we end up with a very interesting scenario here. For this one, we actually need to go back to the definition of the absolute value. Now, I can draw my 0. I can find something that's 9 units away. This is 9 units away from 0. The problem is, if I go the other way, you might think it would be negative. But that's not true. This case, I have positive 9 away is 9. Positive away 9 is negative 9. How in the world am I going to have a negative distance away from 0? Well, this is just never going to happen. Not in the real number system anyway. So we're going to say no real solution. Now, I'd venture to say that this is not going to work in the imaginary system or any other system that I'm aware of, but just to play it safe, since we do tend to work within the real numbers, that is, rational and irrational numbers, we'll just go ahead and say no real solution. There may be some obscure number system in which this may be possible, but definitely not in the real numbers. Okay, let's look at number 6 here. I want to go back to number 5 just for a moment. Why is this so important? If I have absolute value equals negative to begin with, before I look into the negative into the looking glass, there's no possible real solution. If you have absolute value equals a negative number to begin with, before the split, before you split it into two possibilities, that's when you're going to have no real solution. Okay, number 6. Again, I would encourage you to pause the video and try it on your own. Okay, let's try to see how we did. The mirror, the looking glass, is not by itself, so we're going to need to solve for this. So let's add 15 to both sides. Okay, the absolute value of 5x minus 8 equals 27. Now, we have the mirror, the looking glass, by itself. We also have a positive number before the split. That means we can go ahead and split it. So, Alice sees the positive, nice, happy dimension. And at the same time, she sees that there's this also dark, mysterious, negative dimension that she's looking at as well through that looking glass, through the mirror. So now we can actually operate on both of these and try to solve. We're going to add 8 to both sides. 5x equals 35. We're going to divide by 5, and x equals 7. Or add 8 to both sides. We end up with negative 19. Divide by 5. And we have x equals negative 19 fifths. Now you could write that as negative 3 and 4 fifths, but we're just going to leave it as is. X equals 7, or x equals negative 19 fifths. Okay. Let's look at number 7. Now, on number 7, again, you may think, oh, well, it's negative, so there's no way we can actually approach this problem. Well, keep in mind that we haven't gotten the mirror by itself yet, the looking glass, the absolute value expression here. That's not by itself yet. So what we're going to do is we're going to go ahead and solve for the mirror, the looking glass, the absolute value equation. We're going to add 8 to both sides. The absolute value of x plus 2 equals, this is positive 3. Now you notice, even though we had thought initially, oh, there's a negative, it ends up being a positive, so this is something that we can work through. So the absolute value of x plus 2 equals 3. We have the mirror by itself. We're able to be Alice looking through the looking glass. So let's split this into the positive happy dimension, or the foreboding negative dimension. That's probably not the best word. The dark negative dimension. And now we're going to solve. So subtract 2 from both sides. X equals 1, or subtract 2, x equals negative 5. And there we have it. Okay, and number 8. Again, I would encourage you to pause it, try it on your own, and see how you do. Okay, let's get the mirror by itself first. So we're going to subtract 7 from both sides. We have 2/3 times the absolute value of 5 minus 2x equals 2. Here I could divide by 2/3 and then keep, change, flip, or I could simply multiply by the reciprocal. The 3's will divide away to 1, 2's divide away to 1. I could write 1 times, but it's just not really necessary. Let's rationalize the 2, make it into a fraction. 2 times 3 is 6, 1 times 2 is 2, but 6 divided by 2 is simply 3. These also you could think of as reducing to the number 1. 3 times 1 would be 3, divided by 1 is still 3. Okay, we have the mirror by itself. We have a positive number to start with. You must start with the positive. And now we're able to split it into 2 parallel dimensions. Will be Alice looking through the mirror, Alice in Wonderland there. So we have the nice, happy, positive dimension, or the dark, mysterious, negative dimension. Now we can solve for each. Keep, change, change. Keep, change, change. We're going to subtract 5 from both sides. Negative 2x equals negative 2. Divide by negative 2. And x equals 1. Or subtract 5. Negative 2x equals negative 8. Divide by negative 2. And x equals positive 4. So x equals 1 or x equals 4. Okay, and some little notes here. When the absolute value is a positive number, you can have 2 solutions. For example, absolute value of x equals 3. We could have positive 3 or negative 3. That's 2 solutions. When the absolute value is 0, well, think about it. It's either positive or negative 0. Well, that makes no sense. 0 is neither positive nor negative. So you just get the one solution. And when you have absolute value equals a negative number, there's no solution. And I'll add that word, no, real solution. But again, I'm pretty sure it's just no solution, real or otherwise. Thank you very much for watching Crazy Math Productions.